All right. So if we had the system 2x minus 3y equals negative 26, and 3x plus 4y is equal to 12. I'm going to come up with 4 different special types of matrices, but what I'm really curious about is finding 4 different types of special determinants, okay, which we should know how to do determinants because we did that on Tuesday. So the first type of determinant we're going to think about is what's called the coefficient determinant, and we're going to use a capital letter D to represent our coefficient determinant. So D is going to be equal to, if you had to come up with your coefficient matrix, what would it be using that system? My coefficients are 2, negative 3, positive 3, and 4, just the coefficients. And because I'm finding a determinant, I'm going to put bars instead of brackets. Do you remember how to find a determinant of a 2 by 2? Do upper left diagonal first, right?
8 minus 9, so negative 1.
Yeah, make it a different color here. So we're going to do 2 times 4, which is 8. Yeah, minus a negative 9, right? Minus a negative 9, so it'd be plus 9. So my coefficient determinant in this case, so D would be equal to 17. Okay. All right. If we think about our constant determinant, actually it shouldn't even be determinant. This should say matrix, because you can't find the determinant of a 2 by 1. Now think about our constant matrix. Our constant matrix is just negative 26 and 12. Again, we can't find a determinant of that, so I should not have had a determinant there. But we need this when we come up with my determinant of my x, so a subscript of x, and my determinant of my y, subscript of y. So this is what happens. When you find your matrix of your x's, you are going to literally input your values of your constant matrix in place of where the x coefficients would be. So instead of 2, 3, I would input negative 26 for this element, and I would input 12 in place of 3. Okay, so you're going to take your constants and input it in place of the coefficients of your x. So my D sub x determinant would be equal to negative 26, not 3, when I do that, 12, negative 3, 4. What would be the determinant of that matrix? So, oh goodness, 4 times negative 26. It's too early for mental math. Who's got the calculator here? I got the calculator. Yeah, and then we're going to do, so 4 times negative 26 minus negative 3 times 12 gets me negative 68. I can write it out. So negative 26 times 4, subtract 12 times negative 3 results in a determinant of negative 68. So that would be my D sub x determinant. To find your D sub y determinant, where do you think we're going to put the constant matrix? In place of the y coefficients. So now my new matrix is going to be, first column will stay the same, 2, 3. Second column will become negative 26 and 12. Finding the determinant there, 2 times 12 minus 3 times negative 26. So I'll just let my calculator do the work. Sorry if you guys can't see. 2 times 12 minus 3 times negative 26 gets me 102. Okay. So when you see a capital D, so you just need to make sure you know the difference between these 3 notations. If it's just a capital D, it's looking for you to find the determinant of just the coefficient matrix. When you see the capital D with a subscript of x, that means you're taking whatever your constant values are and substituting them, replacing your coefficients of the x with those numbers. When you see a D sub y, you're submitting your solutions or your constants in place of the coefficients in front of the y, and then just evaluate your determinants. Okay? So you think you got the difference of that, because we need those notations for Cramer's rule. So this is what Cramer's rule.
Wait,
Oh.
you bring that back up.
I'm recording this too, so you can always listen to it.
Okay.
So for Cramer's rule, here we got it. So first thing for a 2 by 2. Then we'll get to what it looks like for a 3 by 3, which isn't any much more complicated. So given any 2 by 2 system, where we have a sub 1 x plus b sub 1 y equals c sub 1, a sub 2 x plus b sub 2 y equals c sub 2, it does come along with the stipulation that your determinant of your coefficient matrix needs to be some number other than 0. Because if it's not 0, then what's true? It doesn't have an inverse. And if it doesn't have an inverse, then that means it doesn't have a solution. Okay? So these are the rules that we care about. So to solve for your x value, you are going to find the determinant of d sub x, which we just did in that last problem, and you'll divide it by the determinant of your coefficient matrix. Whatever that result is your x value of your solution. To solve for your y, you take your determinant of that d sub y matrix that you create and divide it by the determinant of your coefficient matrix, and that gets you your y value. So then you'll have your ordered pair x comma y as your solutions. Okay? So this is not too complicated to remember. Your x is equal to d sub x over d. Your y is equal to d sub y over d. You just need to remember what the d of x and what the d of y looks like. That's the tricky part. Okay? So if we go back to that last example that we already found determinants for. So what did we say our d was equal to? Refresh my memory.
17.
It was 17. D sub x we said was
Negative
68 and was d sub y 102. Okay, so we already figured out those values. So now let's solve for x and solve for y. So x would be equal to what over what? Negative 68 divided by 17. Which, what is negative 68 divided by 17? Anything nice? Well, look at that. Negative 4. Lovely. So y would be equal to what ratio? Bless you.
102 over 17.
Good. 102 over 17, which is 6. So my solution to that system would be negative 4, 6. Put it in set notation. So the set of ordered pair is negative 4, 6. Isn't that nice? So you need to decide, do you love determinants or not? 2 by 2s are not that bad. 3 by 3s is where it gets a little bit more extensive in our work. All right, so let's go through one together of a new problem. Is everybody good? All right, so system number 2, we've got 5x plus 7y equals negative 1. 6x plus 6y equals positive 1. So let's figure out our d sub x, and our d sub y. So first, let's do d. D would be equal to, what numbers are going to go in for my elements? 5, 7, 6, 6. Good. Okay, so we're going to do 5 times 6 minus 6 times 7. So 30 minus 42 equals negative 12. So it's not 0, so that means we can actually get a solution. Which if it was 0, if we think about d sub x divided by d, you can never divide anything by 0, so that doesn't work. All right, now let's do our d sub x. Bless you. Bless you. What's my matrix going to look like for d sub x? So remember, for d sub x, we put our constants or our answers in place of the coefficients of the x. So it would be negative 1, 1 in that first column. And then 7, 6 would still remain in our second column. So let's go ahead and find the determinant there. Negative 1 times 6 minus 7 times 1. So negative 6 minus 7 is negative 13. D sub y, what are our coefficients going to be? Well, so that means we're plugging in my 1 and negative 1, 1 in place of the coefficients in place of the y. So I get 5, 6, negative 1, 1, which gets us 5 times 1 minus 6 times negative 1. So 5 plus 6, which is 11. All right. What's your ratio for your x? X is equal to what over what? Negative 13 over negative 12, which would just go to 13 twelfths. My y would be equal to 11 over negative 12. So my solution is the ordered pair 13 twelfths, comma, negative 11 twelfths. Throw it in set notation and make it fancy. Okay, not too bad. Is it easy to remember what these should be for your dx and dy? Okay. All right. So that's 2 by 2s. So what happens with a 3 by 3? We add in a third element. So we still are going to have a dx and a dy, but now we need to add a dz, which doesn't change because now you're going to put this in place of the z to get your dz. It's just now it's 3 by 3, so it's a little bit more work to find the determinants. Okay. All right, so here is a 3 by 3 system. So we've got x plus y minus c equals negative 2. 2x minus y plus z equals negative 5. X minus 2y plus 3z equals 4. All right, so my special determinants are going to be d of x, d of y, d of z. Get this mouse out of here. There we go. So let's do our d first. So we got 1, 1, negative 1, 2, negative 1, positive 1, 1, negative 1, 3. And I'm just getting those.
Negative 2, 3.
Oh, yep, thanks. Good job. Negative 2, 3. So I'm just getting those from my coefficients of my x's, coefficients of my y's, coefficients of my z's. Now to do a 3 by 3, what's the shortcut that we use so we don't have to memorize the formula? We just repeat the first 2 columns. Work upper left first, and then subtract lower left. So let's go ahead and create our diagonals. So here's my first diagonal. That product gets me, it looks like, negative 3. I'm going to put my work up here. Is that too high? Negative 3. My next diagonal gets me a 1. And my last diagonal gets me positive 4. So adding that gets me what? Negative 2, 2. Yeah, positive 2. Now let's do the lower left diagonal. So going in this order. So that gets me positive 1. Where am I running out of space here? Go down here. This diagonal gets me negative 2. So plus a negative 2. And my last diagonal gets me a positive 6. So adding that, that's a 5. So my determinant would be 2 minus 5, so negative 3. Okay. All right, so now let's do d sub x. What's that going to look like? So we're inputting my answers or my constants in place of the coefficients in the x. So that means my first column is going to be the answers of negative 2, negative 5, 4. And then everything else will stay the same. 1, negative 1, negative 2. Negative 1, 1, 3. And then I'm just going to rewrite the first two columns. So negative 2, negative 5, 4, 1, negative 1, negative 2. Go ahead and work through that, see if you can find the determinant, and see if we all get the same thing. That's interesting. Did you guys get that? 0?
You forget to multiply the negative 5 times 3.
Right here, which got me to negative 8. So my first gets me a positive 4, and then here I have a negative 8. Huh? Say it again? Oh, not 8. Thanks. There's my problem. That is right. Good catch. Is that what you were trying to say very nicely, Kayla? All right, so that would be 8 and a negative 15, so negative 6? No, 7. So then it would be positive 7 for my determinant? All right, good snag. All right, so there's our d sub x, which if it did end up being 0, that's okay. That just means then that your x value would be 0, because you can divide 0 by negative 3. All right, d sub y, what would that look like? So row 1's going to stay, a 1 and a 2 and a 1. Now column 2 is going to be my constants of negative 2, negative 5, and 4. And then column 3 will be my z coefficients of negative 1, 1, and 3. Retransfer the first 2. All right, let's see if I can do this one with no error. So we get 1, negative 5, and 3 is not 8, negative 15. Negative 2, 1, 1 is a negative 2. And then we got a -8. So that gets me -25. Going in the other direction, it gets me +5 plus 4 plus -12. So 9 and a -12 gets us a -3. So -25 and a minus a -3, which would really be +3, gets us -22. All right, let me write these off to the side here because I'm going to erase this so I'm not so low. So our D ended up being -3, our D of X ended up being 7, and our D of Y is -22. All right, so D sub Z. Erase this. I'll do my D sub Z up here at the top. So D sub Z, column 1 stays, 1, 2, 1. Column 2 stays, 1, -1, -2. Column 3 now is the solutions, or the constants, so -2, -5, and 4. Retransfer the first two. Let's go ahead and find those determinants. So upper left first. So I got a -4. I get a -5. That's going to get me in +8, which adds together to make -1. Now doing the other diagonals. Lower left gets me, I'm not really describing this really well, I'm assuming you guys are okay with this. So we got 2, +10, and +8, which would be 20. So -1 minus 20 is -21. So any guesses how we would get our X, Y, and Z? My D's.
Oh, 7/3.
Yeah, so let's do our D of X first.
7/3.
So 7 over -3, which would just be -7/3. My D of Y would be
-22.
22 divided by -3, so 22/3. And D of Z would be equal to -21 over -3, which is +7. So we end up with -7/3, 22/3, and 7. Okay. All right, let's practice these. So grab yourself a practice space, whether it's a piece of paper or